Tropentag. So I have a message that we are live. So we are just starting. So good afternoon again. Welcome to this session, which is the food processing session. And we are in the first part of the poster presentations. My name is Jan Banot. I'm a professor at the Faculty of Tropical Agri-Sciences at the Czech University of Life Sciences, Prague in Czech Republic. And it's my great pleasure to be here with you, even online. So the period is strange nowadays, but I think it is quite interesting for us also to have this experience with the virtual conferences. So we will don't waste the time, and maybe is a time to watch the first contribution by Houghton, which is called Effects of Processing Technologies on the Quality of Pasteurized Baobab Nectars Produced in Southern Benin. So if I can ask for the video. So can we have the first?
My name is Mesha Bagiti, and together with my co-authors, we worked on the effect of processing technology.
Okay.
Dear auditors, my name is Mesha Bagiti, and together with my co-authors, we worked on the effect of processing technologies on the quality of pasteurized baobab pulp nectar produced in southern Benin. Acacia digitata is a multi-purpose tree encountered in African savannas. Its fruit, leaves, and seeds are edible. In the last decades, the interest toward the fruit pulp grew due to its multiple nutritional and functional properties. Indeed, it is rich in vitamin C, containing around of 300 mg for 100 gram dry weight of vitamin C, and proved to have anti-diabetic, carcinogenic, antimicrobial, and anti-obesity properties. The baobab pulp nectar was revealed as the main product derived from the fruit and the most consumed. That product needs to be investigated on the ways it's produced, particularly in Benin. So the present study focused on the identification of baobab pulp nectar processing technologies and assessed their influence on the derived nectar quality. For achieving this goal, a semi-structured interview was realized with 34 processing units of pasteurized baobab pulp nectar. At the end of that process, the identified technologies were validated through processing follow-up. For assessing the effects of technologies, pasteurized baobab pulp nectar was produced according to the identified technologies, and derived nectars were analyzed by measuring the vitamin C content, the dry matter, the total titratable acidity, the breeze value, the pH, and the color through the lightness, the hue, and the chroma. As findings, the interview revealed 6 criteria identified as differentiating the processing technologies of baobab pulp nectar. There are the nature of the raw material used, the kind of additive used, the number of filtrations, the number of thermal treatments, the culling nature, rapid or slow, and the primary packages used for the final product. But 2 technologies were validated based on the number of thermal treatments applied, because this preparation seems to be the one with significant effect on the beverage quality. In the case of the first technology, the technology A at the left side of the diagram, the formulated baobab pulp is firstly submitted to bulk pasteurization before its conditioning in bottle, followed by the second thermal treatment, where the bottle nectar is heated. The application of these technologies in controlled environments revealed an absence of a significant difference between both technologies, considering the color, the dry matter, the pH, the titratable acidity, and the vitamin C content. The significant difference observed in the breeze value suggested that the two-thermal treatment leads to a concentration of the sugar and a loss, even not significant, of 29 milligrams for 100 grams of vitamin C content, compared to the technology with a single thermal treatment, the technology B, at the left side of the diagram. In conclusion, we could say that two technologies are used to produce pasteurized baobab nectar in Benin. Both technologies affect the nutritional properties as the vitamin C content. Almost 35% of the vitamin C content is destroyed during the thermal treatments, but the remaining vitamin C content is still high in comparison to conventional fruits as orange. The consumption of baobab fruit pulp nectar should be worldwide promoted. We won't finish our presentation without addressing our thanks to the RU Forum, the National University of Agriculture, the University of Abomey-Calavi, and the Laboratory of Food Science. Thank you all for your kind attention.
Okay, thank you. So we have heard the first contribution. I think the Mr. Gbaguidi is here with us. So any questions?
Yes.
Okay.
Hi, my name's Katie, and was very interesting. Thanks a lot, because I work on baobab as well. Which you see in one of the following posters, and also similar topics. And I wanted to ask you, do you know anything about the pulp more before the processing? How long it was? How long? When the fruits were cracked, how long and how was it stored? Did you also take, do you have any information on that? Because I think that can also have that's what I focused on, and I think that's also important for losing vitamin C in the whole process.
Okay. So Mr. Gbaguidi.
Yes, good evening. But I didn't really get what you are really, what Miss Katie want to know really about the pulp.
So if Miss Katie can repeat.
Yes, if you know the processing, what you looked at started that with the pulp going then into the processing.
Yes.
The baobab pulp. Do you know how this pulp was treated before, or how long it was stored? If the fruits were cracked immediately, and then it was immediately processed, or if there was a waiting time?
Okay. In the context which we have made our experience, the pulp was already extracted. Generally, the pulp is available from January to May or June. And after this period in West Africa, processors, after the harvesting, they extract the pulp and store it in some specific bags. And this pulp we used to make our study, to access the influence of technologies. But the real, when the pulp was harvested, it has a whitish color. And through the storage, the color is degraded, becoming brown with the time. Is it okay?
Yeah, no, that's fine. We're also looking into after harvest, how will the vitamin C degrade from after harvest to the processing during the storage period. That's topics we're interested in as well. So yeah, but yeah,
we have investigating that aspect of the subject. But maybe in future we plan to assess also the variation of these parameters during the time.
Yeah.
So thank you for your suggestion.
Yeah. No. We should get together future studies.
Thank you very much for the nice conversation. So basically, we have to proceed with other contribution. I would like to introduce the contribution of Mr. Abiodun, which is about the quality of as affected by the age and harvest cropping system and variety of cassava roots. So we will try to share this presentation. So there is just a poster, so you have to comment it, please. Mr. Abiodun, are you online? Are you with us? You are muted. Yes, mute yourself. Great.
Yes. Yeah. Good afternoon. My name is Abiodun Adeola. I'm from the Federal University of Agriculture, Abeokuta. The title of this study, as you can see from the screen, is The Quality of Gari as Affected by Age at Harvest, Cropping System, and Variety of Cassava Roots. Gari is a major product derived from cassava. And Nigeria has been adjudged as one of the but unfortunately, up till now, despite being the largest, one of the largest producers of cassava, production of cassava is still in the hands of smallholder farmers. And these farmers employ various agronomic practices that could affect the quality. Study intended effect of the common agronomic practices engaged by these peasant farmers on the quality of gari. So gari was produced from cassava through the traditional processing method, and the proximate composition, the functional properties, the physical chemical properties, and the tasting properties of gari were evaluated. And it was found out that age at which the farmers harvest the cassava has prominent, significant effect on the proximate composition of gari. On the other hand, age at harvest, variety, and interaction of the variety and cropping system had significant effect on the functional properties of gari. Furthermore, the study was able to come up with the fact that all the independent variables, that is the age at harvest, the cropping system adopted, and the variety of cassava chosen have significant effect on all the physicochemical properties of gari that were investigated.
Mr. Abiodun, can I ask you to go to the conclusion because the 3 minutes were exceeded already?
All right, thank you. Now, in conclusion, age at which cassava is harvested has a significant effect on the quality attributes of gari. And among the varieties, the yellow variety named TMS 97JW2, intercropped and harvested at 15 months, produced the most acceptable gari. Thank you.
Okay, thank you very much. The connection was quite problematic, so I'm not sure if we will have some question. Anyway, I will ask if someone has the question to this presentation. I just want to ask you because I went through your poster, which was uploaded to the web pages. Which are the functional properties of this gari?
What are the features?
I'm sorry?
I didn't get you. I did not get you.
Because in your work, you're talking about the functional properties, isn't it?
Yes.
And what do you mean by the functional properties of gari?
Well, the functional properties are things like the water holding capacity of Gary,
Yeah.
the bulk density of Gary. Yes, and the dispersibility, which are important properties in the consumption of Gary.
Okay. Okay, Mr. Abirun, thank you very much for your contribution. And we are going to proceed for other poster presentation, which is called the discrete element modeling of moisture-dependent grain bulk behavior under compressive loading. So it's by Doris Ramay, I think from Hohenheim, isn't it?
Yes, it is. Sorry.
We will wait a little
Dear
bit.
auditors, my name is Doris Ramay, and
Yes, now we have it.
Dear auditors, my name is Iris Ramay, and I am a doctoral candidate at the University of Hohenheim, Institute of Agricultural Engineering. I would like to welcome you to my poster entitled Discrete Element Modeling of Moisture-Dependent Grain Bulk Behavior under Compressive Loading, which was within the frame of a project focused on the aeration of stored grains. Such practices are widely used to force conditioned air through a grain bulk to sustain long-term quality preservation and safe storage. Nevertheless, the bulk self-compaction in these storage structures is a major problem to be addressed, which contributes to ineffective aeration strategies and likely grain deterioration. Thus, this study aimed to investigate the bulk behavior of cereal grains during compression under controlled conditions. The Pioneer A wheat variety at two different moisture contents was used as the testing product. The respective physical and mechanical properties were measured by laboratory experiments, while the complex interaction properties, such as the coefficient of restitution, static friction, and the rolling friction, were determined by calibration tests using an optimization algorithm. In addition, an in-house test apparatus was used to investigate the mechanical behavior of the bulk at a current set of yield stress ranging from 0 to 300 kilopascal at a displacement rate of 1.25 mm per minute. As a computational approach, the discrete element modeling was used to analyze in detail the grain behavior at alike conditions. For DEM modeling, the virtual composition of 5 spheres was found to be the most appropriate shape configuration with a deviation of 0.25% to real wheat grains using the multisphere method. The results showed that the increase in the moisture content contributed to significant differences in the majority of physical, mechanical, and interaction properties which were attributed to structural and texture changes in grain composition. The simulation result of the static coefficient using the piling up test and coefficient of restitution using the drop test are shown graphically in Figure 2 and Figure 3, whereas the summary of all interaction properties is given in Table 1. After the retrieval of all necessary parameters, the compression tests were carried out in both the experimental and simulation frameworks. A good agreement was observed between the simulation and experimental results for different compressive loadings in terms of stress, volumetric strain, and bulk density. The model was able to predict very well both the behavior of dry and wet bulks. From simulations was observed that the dry particles were more likely to roll, dislocate, and expel the free spots through the intergranular voids due to the smaller particle-to-particle and particle-to-wall frictions. They were characterized by lower compressibility, higher stiffness, and lower deformability. On the other hand, wet particles were less likely to realign due to their larger unit volume as well as higher frictions, and were more exposed to higher deformation rates and less to orientation. It can be concluded that DEM has a high capability to simulate the mechanical behavior of grain bulk once the input parameters are properly itemized and should be adapted to the design and optimization of post-harvest handling processes. I would like to thank you very much for your attention, and I would be looking forward to your questions.
Okay, thank you very much for the presentation. So now, one question. Don't hesitate to ask, please.
Can I ask one question?
Yeah, definitely.
Thank you, Iris, for your nice presentation. I just have a question about the DMM model. What is the need of using this model for your work, and how does it actually help?
Okay, so basically we have decided to use discrete element modeling, which is a nice tool to provide or to yield fast, cost-effective, and near-precise results. And it consists of assembly of discrete particles, in my case of grain kernels, with itemized physical and mechanical properties. That would mean that we can identically try to mimic all the properties of one single grain, starting from the particle composition and then giving all necessary properties. And then we can try to study the bulk behavior and to in order to provide some more insights of it. And in such case, we were able to detect the in situ particle kinetics and deformations during different compressive loadings. That was why we used that. Yeah, thank you very much for your question.
Okay, great. So Ziba, please, you can stay with us because the turns is going to your presentation, which is comparison of freeze-thawed and enzymatic pre-treatments to improve peeling processes of cassava tubers. So we are going to hear your presentation.
Good afternoon. I'm Ziba Barati, a PhD student at Hohenheim University. This poster is about comparison of freestyle and enzyme pretreatment to improve peeling process of cassava tubers. Peeling is still considered as the main problem of cassava processing because of irregular shape and size of cassava tubers. The main objective of this study was to investigate and to compare the effect of two different pretreatments, including freestyle and enzyme pretreatment on the peeling process of cassava tubers. A prototype cassava peeling machine constructed at the University of Hohenheim was used to peel cassava tubers. Response service methodology was applied to investigate and to optimize the freestyle and enzyme pretreatment to increase the peeling performance. The variables were thaw temperature, thaw incubation time, and peeling time for freestyle pretreatment, and enzyme dose, incubation time, and peeling time for enzyme pretreatment. Peel surface area and peel loss were determined as the main response factor in this study. As you can see, peel surface area and peel loss were calculated according to the presented formula on the poster. As a result, peel surface area and peel loss were significantly influenced by freestyle pretreatment and enzyme pretreatment. Figure 2 shows the surface plots indicating the effect of variable on peel loss after freestyle pretreatment and enzyme treatment. And figure 3 shows the surface plot indicating the effect of variables on peel surface area of cassava tubers after freestyle treatment and enzyme treatment. We found that under an optimum peeling condition, the peel surface area of 94.9% with peel loss of 21.7% for freestyle pretreatment and peel loss of 89.5% with a peel loss of 24.6% for enzyme pretreatment. Freestyle pretreatment could result in a higher peel surface area compared to enzyme pretreatment, but also leads to the synersis phenomena that influence the quality of the tuber in terms of texture and water content. Moreover, enzyme pretreatment could increase the detoxification of the peels by hydrolysis. We found that application of both freestyle and enzyme pretreatment can be an effective approach to improve the peeling process of cassava tuber. However, these pretreatments would add extra costs for cassava processing. Therefore, the feasibility of these methods at industrial scale should be further investigated. Thank you very much for your attention.
We thank you as well, Ziba, and there is a place for question.
I do have a question, sorry.
Yoris, please.
Yeah. Thank you, Ziba, for your presentation. My question would be, which of the two methods that you presented would you recommend for the practical application that would best compromise the peel surface area, peel loss, and the product quality? Thank you.
Yeah, thank you, Aris, for your good question. In my opinion, the enzyme pretreatment had a higher potential to use in the industry scale, because the enzyme is the environmentally friendly method and can contribute in the food processing in a sustainable manner. And also it can improve the quality of the peeled product and also the efficiency. However, it can also add extra costs for the food processing, and it's possible in future study to recycle the enzyme solution and reduce the cost.
Okay, thank you very much. So let's go for the another poster, which is going to be presented by Sami Ulach, and the title is Management of Post-Harvest Fruit Softening and Quality of Peach by Calcium Chloride. It's without sound. Unfortunately, we cannot hear the presentation, I think. Anyone can hear the presentation? We just see it. Good. Maybe if Sami is here with us. No, I cannot see him in the list. Mr. Sami, are you here with us? No? Good. Anyway, we have to skip this presentation and let's go further for other, which is by Solomon Coffee. And this is about orological properties of orange flesh, sweet potato, pumpkin, and wheat blended flour doughs, and quality characteristics of breads. So we are going to have two posters by the same presenter. If I can ask.
I'm Solomon Coffee.
Yeah, great.
By a PhD candidate in the University of Cassava in Germany. I'm making a poster presentation on the orological properties of orange fresh sweet potato, pumpkin, and wheat blended flour doughs, and quality characteristics of breads. Introduction. There is high demand for new bread products that have high nutritional benefits and good eating characteristics. It was reported that gluten-free flours incorporation in bread production will improve on the nutritional value and quality characteristics of bread. Orange, fresh sweet potato, and pumpkin have the potentials to improve nutritional benefits and eating quality of wheat composite bread. However, incorporating gluten-free flours may influence the dough and bread quality characteristics. This study, therefore, aimed to optimize wheat OFSP pumpkin dough and bread quality characteristics using response surface methodology. The experimental design was done using iOptimal combined design of the Design Expert software version 11. A total of 27 experimental trials were constructed with 5 lack of fit points, 5 replications, and a central repeated point. Wheat flour was replaced with OFSP in the range of 10 to 50% and pumpkin between 10 to 40%. Baking temperature was between 150 to 200 and baking time between 15 to 25%. Bread preparation, dough, and bread quality assessment were done using ICC standard methods. The results obtained shows that OFSP flour and pumpkin flour influence the farinograph properties. It was observed that wheat flour, high levels of wheat flour has higher optimum water absorption. And as the OFSP flour and pumpkin flour increases, optimum water absorption decreases, as can be seen in figure 1. Dough development time also increase as pumpkin flour levels increase, and also as OFSP flour increase. However, the effect of pumpkin flour on dough development time was higher than that of OSP flour. Dough stability time, however, decreased as wheat flour levels increases. And this can be seen that wheat flour levels have high levels of wheat flour at lower stability time as compared to high levels of pumpkin flour and OFSP flour. The bread quality characteristics assessment revealed that OFSP and pumpkin flour decrease low volume and specific volume, as shown in figure 3. We can see that as the level of OFSP flour increases, specific volume decreases. Also, baking temperature, increase in baking temperature, decrease specific volume of bread. The texture profile analysis of breadcrumb also revealed that OFSP and pumpkin flour increase bread crumb hardness and chewiness, whereas cohesiveness, springiness, and resilience decrease. The color of bread crumbs were also affected. Lightness of breadcrumbs decrease as OFSP and pumpkin levels increase, while redness and yellowness increase with increase in OFSP and pumpkin. In conclusion, the optimum rate of OFSP and pumpkin flour in wheat flour for bread making were 30% and 12% respectively, and baking at 160 to 180 degrees Celsius for 15 to 17 minutes produce bread with good qualities. The authors would like to acknowledge the financial support from the Upgrade Plus project, which was funded by the German Federal Ministry of Food and Agriculture via the Federal Office for Agriculture and Food.
Good. So I can see that Mr. Coffee is not here with us, so basically it doesn't make sense to ask questions. And as the second presentation of Mr. Coffee is almost similar, we are going to listen the presentation of Catherine. Before that, I would like to ask Mr. Abiodun. Yeah, he is muted now. Great, perfect. Everything is working. So Catherine is going to talk about quality of baobab.
Hi.
Definitely baobab products across their value chain in Malawi. So we are going to hear the presentation of Catherine.
Hi, and welcome to my presentation on the quality of baobab products across their value chain in Malawi, which is part of my PhD research, and also integrated into a more broader project on baobab in Malawi. So the focus is on Malawi because baobab is a very highly commercialized fruit here. So as you can see in these pictures, you find the fruit on the market, but also the pulp, and there's a variety of different products available as well, like these informally produced ice lollies or the more professionally produced juices. However, there's relatively little information available on the quality of these products and any difference between these more informal and the formal value chains, particularly regarding the vitamin levels, which is what baobab is most famous for, or if there's any microbiological contamination. So these are the points we wanted to look at in this study, and we've done this by using a mixed methods approach. So we carried out semi-structured interviews with different baobab value chain members and interviewed them on their perception and quality, what is important for them in terms of baobab, while simultaneously also collecting samples and having these analysed in the lab for vitamin C and mycotoxins. Here, as a first result, you can see the different commercialization pathways for baobab products in Malawi, highlighting the more informal way and as well as the more formal pathway. The informal one, that goes mainly through the collectors and different types of traders and middlemen to the processors of these ice lollies, which are then sold predominantly to children via different informal markets. While the more professional juice producers, they can obtain the baobab also in various ways, either from traders or directly from collectors or collector association, and then target more middle class consumers via supermarkets or pharmacies. Looking now at the different quality indicators, so overall the dryness of the fruit and the colour of the pulp, which would be white, were identified as being the most important quality characteristic. However, there were also significant differences between the formal and informal value chain members, especially concerning whether there are cracks in the fruit or how clean the pulp was. This was a much higher interest of the formal value chain members. Furthermore, we could show that with regard to the vitamin C levels, whenever there's a powder produced and the powder is then being further processed, that the vitamin C level is a lot lower than when you're using the fruit directly or the pulp. So it's best to keep preferably you use the fruit or the pulp directly before processing rather than powder. And finally, we were also able to detect aflatoxin in 2 of the samples we investigated in a level above the EU threshold for dry fruits. So we can conclude that it's best to process baobab into powder and then into the final products as late as possible, so we have the most of our vitamin C. And then there is a risk of microbiological contamination on whole, although it is a very dry fruit. It is possible that this contamination occurs. So overall, there's more awareness needed with regard to handling and processing of baobab in both value chains, and formal and informal ones. So with this, I'd like to conclude. Thank you very much, and I'm happy to answer any questions.
Katie, thank you very much for your virtual presentation. Now we have still some time for maybe more than 2 questions, if anyone wants to ask. Maybe I will start with one in terms of the aflatoxins. Which kind of aflatoxins you measured? I didn't get it. Did you estimate also the sum of aflatoxins or just aflatoxin A?
No, all B1, B2, the sum, and ochratoxin.
Yeah.
Well, yeah. So we had, I think in the sample that was most contaminated, that overall it was 9 micrograms per kilogram. B1 was the most, 5 micrograms from that was due to the aflatoxin B1.
Yeah, so it seems that it's quite well under the, for instance, the EC limits for the food.
That was 2. I think the limit, the threshold, I think, is 2 micrograms per kilogram. So
and this is because of the handling method.
That's we want to go more in depth there, but we could see some fruits that are picked. Yeah, well, that's what a lot of them say. No, it's not important if there's a crack and then moisture comes in. So we're not quite sure yet at which step it occurs. So that's that will be the next steps we want to look in. But yes, people do pick baobab, which is either it falls down and has cracks, but also sometimes they harvest maybe too early because they just they want to have cash and make money, and then it's not fully ripe and not fully dry yet. So
I think the moisture is the crucial issue maybe here.
Yeah.
Moisture during the harvest. And then, of course, this is the question of the storage method.
Yeah.
Because those mycotoxins are developed, especially in the humid environments. So maybe there is a problem if they are sometimes they are not appropriately stored with badly aerated places. That could be one of the problems. Okay, thank you very much. Any other questions? About baobab, it's a very interesting tree, isn't it? So do not hesitate. I will just check the VOVA application. There are also no questions to you, Kate. So thank you very much for your presentation. We have the last one presentation, which is by, again, Mr. Solomon Coffey. So he is not here, so maybe we just can look at the video and then there will be no discussion. I don't know if we still have this last one video about the effect of incorporating peeled and fresh sweet. Yeah.
Kofi Chekpa, a PhD candidate in the University of Cassava, Germany. I am making a poster presentation on the topic effect of incorporating peeled and unpeeled orange fresh sweet potato flour on neurological properties of dough and quality characteristics of bread. Bread consumption in sub-Saharan Africa is increasing. However, the main ingredient for bread making, wheat flour, is imported. Therefore, the substitution of wheat flour with gluten-free flour, such as orange fresh sweet potato, will help to improve on the nutritional value of bread and also minimize wheat flour importation. Therefore, this study investigated the effect of replacing wheat flour with peeled and unpeeled OFSP flour, as well as the effect of baking conditions on bread quality characteristics using a response surface methodology. The optimum combined design of the design expert software version 11 was used for the experimental design. A total of 17 experimental trials were created, which has 5 replications, 4 lack of feed points, and a central repeated point. The range of wheat flour was between 40 and 90%, and OFSP flour between 10 to 60% were used. And the baking temperature was set between 150 degrees Celsius and 200 degrees Celsius, with a baking time of 15 to 25 minutes, each having 6 levels. The bread was prepared using ICC standard method 131, and the dough properties was analyzed using farinograph. The bread quality characteristics were assessed after the freshly baked bread was allowed to cool for 2 hours at room temperature. Volume and specific volume, weight of the bread were measured using standard methods. Texture profile analysis on breadcrumbs was also analyzed on the freshly baked bread and also at 24 hours interval during storage in a climatic chamber at 25 degrees Celsius and 85% relative humidity for 3 consecutive days. The results of the study showed that farinograph optimum water absorption decreased while dough development time increased as the rate of OFSP flour increased. Dough stability time and degree of softening improved as OSP level exceeded 35% inclusion. However, it was observed that unpeeled OFSP flour incorporation has higher or resulted in higher optimum water absorption than the peeled OFSP flour. The baking laws, low volume, specific volume, crumb moisture content, and water activity all decrease as OFSP flour, baking temperature, and baking time increase. The texture profile analysis revealed that crumb hardness and chewiness increase, while cohesiveness, springiness, and resilience decrease as OFSP flour incorporation increase. And figure 1 shows the effect of flour proportion and baking temperature with a baking time of 20 minutes on specific volume and hardness. The crest and crumb color were also measured using the calorimeter, and the crumb lightness were affected by the flour proportion, baking temperature, and time. It was observed that lightness decreased as OFSP flour increases, whereas lightness also decreased as baking temperature and time increase. Figure 2 shows samples of bread Conclusion: the degree of wheat flour substitution with OSP flour, baking temperature, baking time had a significant influence on all the quality characteristics of bread. Wheat peel OSP composite bread has higher specific volume and hardness but lower moisture content. It was observed that replacing wheat flour with OFSP flour up to 35% and baking at 160 to 180 degrees Celsius for 15 to 17 minutes can be used to produce quality composite bread. The authors acknowledge the Upgrade Plus project for the financial support, and the Upgrade Plus project is being funded by the German Federal Ministry of Food and Agriculture via the Federal Office for Agriculture and Food. Thank you for your attention.
Okay, thank you very much for all of you. So for your presentations. The session is closed now. I'm running for the other session. We have 2 poster sessions, so I meet with some of you after 10 minutes in another room. So thank you again and have a nice evening. Goodbye, everybody.
Thank you very much.
Thanks. Bye-bye.